Hello, everyone. Welcome to Module 2 in our discussion of Industry 4, which is about Industrial Internet of Things, IIoT. So let's understand why IIoT is the backbone of Industry 4. So let's start with IIoT and how it fits into the larger picture of Industry 4. So we'll discuss some core concepts, technology, and why IIoT is very important to modern industrial environments. So this IIoT is a branch of IoT specifically focused on connecting devices, machines, and systems in industrial settings like manufacturing plants, energy grids, and logistics. The IoT enables these industrial assets to communicate with each other and with centralized systems, allowing businesses to automate processes, gather and analyze vast amounts of data, and improve efficiency. So if you start with the definition of it, IIoT refers to the application of IoT technologies like sensors, connectivity, data processing, etc., specifically within industrial settings to boost efficiency, automation, and real-time monitoring. So, unlike consumer IoT like smart home devices, IIoT focuses on heavy-duty environments where reliability, security, and scalability are essential. So, for example, in a car manufacturing plant, IIoT can connect robotic arms, conveyor belts, and quality control cameras to a centralized system. So, this way, each piece of equipment can communicate its status, detect issues, and coordinate tasks to streamline the production process. So, now let's understand why it is important in industrial settings. So this is a game changer in industrial settings for several key reasons, starting with enhanced productivity. So IIoT allows machines to work smarter, not harder. By automating routine tasks and enabling machines to talk to each other, IIoT reduces human intervention and allows factories to run continuously with minimal downtime. Then comes the predictive maintenance. So with IIoT, companies can move from reactive maintenance, which is fixing things only after they break, to predictive maintenance, like fixing things before even they break. So sensors can detect early signs of wear or performance issues, helping to prevent unplanned downtime and reduce maintenance costs. Then with real-time decision making. So IIoT enables factories to collect data from across the entire production process and analyze it in real time. This means managers and operators can make informed decisions on the fly, be it is adjusting the production schedule or addressing a bottleneck. So these are few of the important characteristics and why IIoT is exactly important in industrial settings. So let's briefly understand what are the core components now. So there are several core components, few of which are sensors. So these are the eyes and ears of IIoT. So they gather data on pressure, speed, vibration, and more, enabling the system to monitor various aspects of the physical environment or machine status. So for example, in a chemical plant, sensors can monitor temperature and pressure in tanks, ensuring they remain within safe limits. Then the connectivity. So data gathered by sensors needs a way to travel to other systems for processing. So this connectivity involves the communication technology and protocols, the Wi-Fi, the Ethernet, the 5G network that enable data transfer from devices to central platforms. Then the data processing. So the raw data from sensors often needs filtering, cleaning, and processing to make it meaningful. So the data processing can happen at the device level or on-site level or in the central location. Finally, the analytics. So analytics is where data turns into insights. So by applying analytics and ML models, IIoT systems can identify patterns, predict outcomes, and suggest actions for improvement. Finally, if we take up few technologies enabling IIoT, we'll start with the cloud, which provides scalable storage and processing power for IIoT data. So it allows companies to store large amounts of data from multiple facilities, run complex analytics, and access data remotely. So this cloud computing also supports collaboration across locations. That is one. Then we have this edge computing. So edge computing processes data closer to where it is generated, such as in the shop floor. So this reduces latency, which is crucial for time sensitive applications and minimizes the amount of data sent to the cloud, reducing bandwidth costs. So, for example, in a factory, an edge device can instantly analyze sensor data to detect anomalies, stopping a machine within milliseconds if it detects a dangerous condition. Then we have this fog computing, which is a middle layer between cloud and edge computing, allowing for distributed data processing within local networks that is closer than cloud but farther than edge. So it is helpful in large scale setups where processing needs to be shared across locations. For example, in a distributed manufacturing setup, fog nodes can handle local data from multiple machines, sending only summarized or relevant data to the cloud, which reduces network congestion. Finally, the AI and ML part are used in IIoT to analyze complex data sets, detect patterns, and make predictions. So the ML models can learn from past data, making IIoT systems smarter and more capable of automating complex tasks. So IIoT is all about connecting and optimizing industrial assets to improve productivity, reduce downtime, and enhance decision making. So this is all about IIoT.